This is the wild Grose River in the Blue Mountains National Park of New South Wales. The valley is so deep, it's like the landscape has been turned inside out.
We underappreciate how important these ecosystems are. It's out of sight, out of mind. It's exciting in a sense to come and do fieldwork in these sorts of areas, but it's really bloody difficult too.
The challenge is, to understand what drives life in this valley, you have to get to the bottom of it, 600 metres down. This ancient landscape is carved by a river whose future health depends on a hidden world of tiny insects. But it's not as pristine as it looks. Freshwater ecologist Ian Wright knows the insects struggle with pollution and that something mysterious is killing them.
One of the central aims of my research was to illustrate if you're trying to protect these ecosystems from a pollution source, why don't you measure the ecosystem? Why don't you measure the plants and animals actually living in it?
There are thousands of aquatic invertebrates living in every square metre. Ian reads their abundance and diversity as biological indicators of the river's health. Many are larvae of better-known insects that fly, like mayflies and midges.
This sample is absolutely teeming with life.
As krill are to whales in the ocean, these insects are the mainstay of life in the river valley. Growing up for most of their lives in the water, some are sensitive to pollution, others more tolerant. Here, dragonflies are jet-propelled ambush predators. Caddisfly larvae graze the algae like herds of cows.
I found 48,000 different invertebrates living in the waterway here at the sites across 54 groups.
"15 years ago, Ian worked for Sydney Water. Ageing sewage treatment plants used the rivers of the Blue Mountains to dump their waste. His job was to monitor the impact of that pollution. Now just one antiquated plant still remains on the Grose River. Every day it releases 1 million litres of tertiary treated sewage down the hill.
That's the effluent from 5,000 people in the Blackheath area.
And this is where it hits the Grose River?
This is where it comes into the Grose River catchment. This seems like a very small flow of water, but there's massive loads of nutrients in here. So this flow is strongly affecting water quality for 20, 30 kilometres downstream.
Now with the University of Western Sydney, Ian continues to monitor how the chemical changes affect the biology.
The conductivity's risen from 34 microsiemens to 336 microsiemens here, so it's a tenfold increase.
It is, yeah.
Although the plants and animals here are adapted to low levels of nutrients,
temperature 10.6.
The sewage adds 1,000 times more nitrogen and phosphorus to the river.
It's like fast food to the ecosystem. There are several species down here right now we don't even know the names of that we're probably killing.
Upstream of the sewage discharge, Ian expected the river to be a natural baseline for his pollution research. He was in for a nasty surprise.
There were some animals living there, but whole suites of animals that we expected were actually missing. There was clearly something going wrong.
Chemical data showed high levels of zinc in the water. Ian worked his way upstream, checking each tributary to see where it was coming from. He'd heard there was an old mine at the very top of the catchment.
We wouldn't be getting through here if it wasn't for the big bushfire that came through.
Now Ian is leading us to a part of the Blue Mountains where people rarely go.
There's no formed tracks around here.
So more than most
to the very headwaters of the Grose River.
We'll drop down to the creek here, and the mine's about another 200 metres down here. But
that doesn't sound like far.
No, it's almost 200 vertical metres though. Watch the very low rock there, Mark. See, there.
That's incredible. It looks kind of wrong.
It is impressive in a frightening sort of way.
And how long did it take you to actually find this spot?
Well, it really took 15 years.
700 litres a minute, more than 1 million litres a day, has been pouring out of this abandoned mine for more than a decade. Creeks and groundwater seep through cracked rocks and fill the holes left by mining. Left behind is an unusual case of acid mine drainage.
This is what they've been mining here since the 1950s, coal. The mining process itself, by exposing the seams to oxygen, creates the acidic conditions. And it's that acid that liberates the zinc that's now pouring into the Grose River.
All this in one of Australia's most environmentally valued rivers. It's designated as a wilderness area, protected as a national park, and listed as World Heritage.
At the moment, I'd say around 15 to 20% of the flow in the upper Grose River is actually coming here of this coal mine. It's full of zinc. It's full of lots of metals. We've got iron, manganese, aluminium.
The colours here tell the story. On this side, the pure headwaters of the Grose River. On this side, the toxic waterfall spewing out of this old coal mine. There's 100 times more zinc in here than there is in here. And this is where they join.
500 micrograms of zinc per litre from the mine is well above the toxic limit.
What is of most concern to me in there is that the metal zinc can be highly toxic to the aquatic environment.
The Environment Department that once set pollution limits for the mine is still responsible for protecting the river.
I really don't understand why the EPA hasn't done something about this pollution. Perhaps the fact that they licensed it, and licensed it at I would say, levels that are hard to defend now, and then walked away. It's 11 years since the mine shut down.
We do know that the zinc levels have dropped by an order of magnitude since the mine closed in 1997, and they will continue to drop over the next period of time as well, till they eventually reach the background levels.
Should the water continue to enter the Grose River?
Absolutely not. If we want to see healthy ecosystems in the Grose River and its tributaries, this needs to be stopped.
It's only above the mine that life is as it should be.
Yeah, we've got lots and lots of leptophlebid mayflies.
There is, yeah.
Now, they are my, if there was a canary in the coal mine or a canary in a polluted river under the coal mine, that's it. And same under the sewage plant.
Okay.
Never ever found a leptophlebid mayfly.
Never.
Very, very, very sensitive animal.
If pollution is removed, these tributaries can replenish the diversity in the rest of the river.
Under the coal mine, we're getting an 80% reduction in the actual numbers of invertebrates and about half the diversity of groups.
That's a pretty staggering figure.
That's a major pollution impact. But similarly, the sewage treatment plant is just as big, but it's a different type of impact. The actual numbers go up, but the diversity reduces.
But there's good news for the river. This is the last time you'll see this relic of the past.
For 70 years, this sewage treatment plant here at Blackheath has been pumping effluent into the Grose River. Now it's the last of 10 of these old plants from the Blue Mountains to be shut down and the sewage pumped elsewhere.
It's great news for the EPA as well, which licenses the pollution that Sydney Water can discharge.
For quite some years now, we have not accepted dilution as the solution to pollution.
Pulling the sewage out, that is fantastic, and that is something to be celebrated.
But further downstream, there's a catch. The sewage is helping to dilute the zinc.
Probably about 20% of this flow here is due to the toilets flushing in Blackheath. Take that out, that zinc is actually going to get worse. The zinc concentration will rise and the plume will actually extend down, that toxic plume. It could come this far. What is quite frightening is with all this life, you can actually get the zinc absorbed into the food chain and bioaccumulate in animals.
Are you concerned that this could create a precedent that would allow this kind of pollution in other rivers?
Yeah, absolutely, and I think that would be a sentiment that a lot of the community would share. We're riding the crest of a mining boom in Australia right now.
It begs the question, with more than 20 new coal mines proposed for New South Wales alone, What's to stop them also leaking acid and heavy metals into rivers? The fact is, there is no specific legal requirement to ensure that every new coal mine avoids acid drainage in the first place. Ian won't relax until the legacy of this old mine no longer poisons the Grose River.
That would be my dream. I think it'd be great if we could fix this and show a World Heritage area coming back to life from pollution.